Hello everyone. Today we would like to present you our research topic of the Internet of Things security. IoT is a technology uses sensors to collect information from objects. It realizes intelligent perception, identification, and management of things with access of various networks. This presentation will be structured into 3 parts, demonstrating the security architecture, the REST API, middleware, and the applications. Speaking of the architecture of IoT security, the typical one has 3 layers. Perception layer is responsible for information perceiving and collecting. The main challenge is to embed a lightweight security protecting system with good computational power into devices. Network layer is responsible for information transmission. It faces not only those traditional attacks such as reply and proofing, but also new challenges of authentication, key agreement, etc., due to the increase of the protocols. In the application layer, the increase in number of IoT devices could increase the scale of DDoS attack, and it has the closest contact with users. Hence, the most critical task is to protect user privacy with strict permission control while developing the cloud serverability. 2 general modules exist based on the basic structure of IoT we previously mentioned. They are centralized IoT and distributed IoT. The centralized module has a central entity, in some cases a controller, to process the data and combine for users. In contrast, the distributed module allows all entities to retrieve and process information with each other. In comparison, distributed module has superior fault tolerance over the centralized one while maintaining high interoperability. But centralized module faces less security management challenges like access control.
In this part, I will be mainly discuss about the middleware and IoT gateway. There is a solution proposed which provides a middleware architecture and is able to adapt according to application requirements. In the proposed model, IoT devices are connected locally through non-IP networks and are connected to the internet through an intelligent gateway. This gateway acts as an interface to the internet for IoT devices. Middleware is responsible for this device registration, identification, and database management. It also ensures the privacy and security of data. The stored data is exposed after authentication and authorization via REST API. The following figures explain the architecture to achieve the workflow. Step 1. Device registration requires an authorized user who already has created an account through middleware. Step 2. Whenever an authentication request comes from the IoT device, Gateway validates the device request, including the device payload, by accessing the exposed REST API. Now, the gateway will in turn request access to the exposed API with its own credentials. The request will contain gateway ID and secret key as input parameters. The API will both authenticate and authorize the gateway and will validate the request. All methods in REST API requires authentication. Once the gateway is authorized, a response in an encrypted form containing device details is sent back to the gateway. Now, after verifying, Gateway gives the access token to the device, and device can now send real-time data to the gateway. The proposed IoT framework that ensures end-to-end security from IoT application to IoT devices. We can evaluate the security of the system by analyzing the integrity of each component. IoT devices are isolated and have no interaction with the outside world. Therefore, there are no chances of compromising these devices by an attacker. IoT gateway are enabled to call REST API and exchange all information securely. Authentication and authorization is taken care by REST APIs, which makes the whole process less complex and compatible with industry standards.
Hi guys, next I will talk about the applications in IoT. Reckoned as the objects interacting and communicating information with other objects through wire or wireless medium, the concepts of Internet of Things gradually penetrates both our daily life and workplace and pave their way into the development of numerous applications. For instance, we can monitor the electronic items in home and report real-time traffic situations via home automation system and intelligent transportation system. Moreover, remote treatment can be taken for patients under telemedication. Nevertheless, the security is supposed to be concerned for all connected devices. Firstly, since most IoT devices are connected wirelessly on public network with shared sensitive information, they are likely to suffer from vulnerable malicious attacks. Furthermore, in an IoT network, interaction process is risky where each object in the network is unable to identify and authenticate others without any related mechanism. Besides, privacy-related threats has increased manifold, while objects are traceable through an IoT network. Hence, security of users should be considered, and their data ownership collected from different smart objects need to be established as well, so that related information will not be privileged without their consent. As for the solution, numerous techniques are proposed where hybrid models of encryption and authentication algorithms are made, but they will lead to the increase in required device memory. Hence, the usage of live-wire cryptography is indispensable in ensuring security. As defined, it is an encryption method that features a small footprint and low computation complexity. Meanwhile, it is aimed at expanding the applications of cryptography to constrained devices. Diverse from traditional encryption methods, live-wire cryptography can work within the confines of a simple electronic device, even under limited resources. Moreover, it provides the same level of security where the large number of rounds degrades the performance. And for future direction, we will analyze more aspects in our reports regarding model comparison and insights. And that's all. Thanks for listening. Here's our reference.